So I've done a couple proof by induction videos, but there's one other type that I haven't hit yet, which is proving a derivative formula using induction. So for example, if I'm looking at this function, where it's x squared times e to the x, I would like to prove that the nth derivative has this formula, x squared plus 2nx plus n minus 1 e to the x. Alright, so x squared, 2nx, n minus 1 e to the x. So first step, base case, let's look at the first derivative. Product rule. F prime g plus f g prime. If I look at my formula that I'm trying to get to, I want to factor out e to the x. So I have 2x plus x squared e to the x. Then let's force that to be in the format using n. So I did the first derivative, so n is equal to 1. So that's x squared plus 2 times 1x plus 1 times 1 minus 1, because that term disappeared. 1 minus 1, and then e to the x is still there. Step 2 is going to just be assume, and you're going to write it down on the test. You're going to write down exactly the induction hypothesis, and then we're going to consider the n plus 1th derivative. Well, the n plus 1th derivative is the same thing as the derivative of the nth derivative. And what's really crucial is we have an induction hypothesis for the nth derivative that we can drop right in there. So what we have to do now is take one more derivative of our formula. X squared plus 2nx plus n minus 1, all that times e to the x. I need to figure out why this pen is not working on me. Okay, so we're going to do the product rule one more time. F prime is 2x plus 2n. F prime g is just e to the x plus f x squared plus 2nx plus n times n minus 1 times g prime, which is e to the x. Both those terms have an e to the x in common. I can already see where the x squared comes in. If I factor out an x, I can see that I have 2 plus 2n. And if I look at the constant terms, I can see I have, distribute this, n squared minus n plus 2n. This middle term becomes 2 times n plus 1, which is what I wanted. And that's an x right there. X squared is just hanging out. And this n term, if you can combine the negative n and the 2n, you get a positive n, becomes n times n plus 1. If you look at the nth version of the derivative formula, you can see what we did is we put an n plus 1 right there, put an n plus 1 right there, and put an n plus 1 right there. So we proved the statement for all n. All right, thanks for watching. Please ask questions. Happy to help.